Let's derive the equation for the directrix and the parabola. So let me recall what we are looking at. This is the structure of a parabola. To draw this, we need something called as focus and something called as directrix. So this is your directrix and that's your axis, and this is your vertex. This vertex is on the origin, so I'll write it as O. This point I'll call it as M. I've written the write up over here. So we are looking for the equation of the directrix and this particular line, right? Now let FM be the perpendicular to the directrix and bisect FM at the point of O. So this is your FM and it's getting bisected at point O. I would like to discuss why is it getting bisected at O, right? How do you know that? See, the point of a parabola is what? That the distance are equal, is it not? That's your focus length, this is your projection length. The lengths are equal. So what happens at this point? Obviously this length will be equal to this length. Do you guys agree? So those lengths are equal, right? So by default, the definition itself tells that they have to be equal. This is a point on the parabola. So to the focus and to the directrix, they have to be equal. This is the perpendicular. So they have to be equal. And this entire length, I'm taking it as 2a. So basically, this length is a and this length is a. Now, before we start deriving, let's derive the basic aspect of this particular figure. If I take this as f, which I have taken already, how much is OF? The length OF is a. Now, since it's on the x-axis, we'll consider this to be on the x-axis. So can you tell me the coordinates? Yes, it is a comma 0. Anyways, y is 0. It's a units away, so it has to be a comma 0. Now, what about point M? Right, since the y component is 0, it's to the left, a units to the left of the origin. So it's minus a comma 0. All of this is going to help. Now let's consider a point, say P, somewhere over here. So that's point P, x comma y, representing the general point of the parabola. If I join this length should be equal to this. Of course, my diagram does not look like it because my focus is way ahead than what it's supposed to be. The focus is supposed to be here, but because of diagram, I changed it because of the requirement. Let me call this point as B. Now, can you tell me the coordinates of point B? Think of it. Let's do step by step. How much is it to the left? A units. Since from the origin it's a units to the left, so it has to be minus a, comma. How high it is? It is y. The reason being, see, this point P is at x comma y. That is, it's at a height of y. And this line is perpendicular, this is perpendicular, so this has to be parallel to this. So obviously the heights have to be equal. It becomes a rectangle, is it not? If I drop this, it becomes a rectangle. And so this height is minus a comma y. Coordinate is minus a comma y. Now let's talk about the equation of the directrix. Okay, so we'll start off with as the line is parallel to the y-axis. It should be of the form. Yes, it should be of the form. Correct. X is equal to a constant. It should be of this form. Is it not? So x has to be equal to minus a, right? And that constant is minus a. So this line is x is equal to minus a. So that is your equation of the directrix for this particular case. There are 3 more cases, remember. You don't have to derive all of it, but yes, we need to understand how we got it. So x is equal to constant is the equation of a line which is parallel to y-axis that you guys should know by now. We have done this. x is equal to minus a is that constant. Moving on, we have the equation of parabola. Again, we need the graph for that. So how is that we're going to derive this? Remember, we have points to be at equidistant. So now, using the fact that PF should be equal to, it's not, I know, should be equal to PB, reason being, that's the whole idea of distance of focus to a point on parabola will be equal to distance of the same point to the directrix. You guys agree? Well, you have to agree. That's the whole idea of parabola. Now, so we'll make use of distance formula. So we know the lengths are equal, so we have to make use of distance formula. As simple as that. x1 minus x2 square plus y2 minus y1 square. This entire thing, root of that. And now we have x over pf. Pf is over here, so x minus a the whole square plus y minus 0 the whole square, root of this is equal to, then we have pb x plus a the whole square plus y minus y the whole square, root. So basically, what all can I cancel? Well, I can cancel the roots. The roots got cancelled. You can imagine it so, because, well, I can't do it now. It just look cumbersome over there. Now let me expand x minus a the whole square. So x square plus a square minus 2ax. And this is y square. Right? The roots have cancelled, remember. So we have cancelled that. And then we have x square plus a square plus 2ax, and this is 0 square, that is 0. So further cancellation involves x square both the sides, a square both the sides. So this is minus and this is plus. They are not the same capacity, same magnitude, so they can't be cancelled. All I have to do is rearrange this. Y square is equal to, if I transpose it, I'll get 4ax. They're like terms, I can add them. And we have the equation of this particular parabola. Okay, so this is your derivation of one of the possibilities, one of the possible parabolas.